So these roles are very varied in what they do, and just beyond, there are roles beyond the electron transport chain in the process of ATP, even though probably all the way back from elementary school when you're learning about the cell and the parts of the cell and probably the nucleus and the mitochondria, and they always say mitochondria is the powerhouse or the energy house of the cell, and that's true. Okay, the mitochondria, if you think back to last semester when we were going over, actually I think it was right around the time I got sick, so it would have been probably the time that Dr. Schraw took over, and you guys did lipids. If you think back to the composition, remember the membrane, cell membrane is made up of both lipids and proteins, and one membrane in particular that's so highly proteinaceous is that inner membrane of the mitochondria. And so there's one, I don't know if you actually ended up using my slides, I may have not, but there's one where I'd always point that out, and I'd say, what's the whole purpose? Like, why are there so many proteins in the inner membrane of the mitochondria? And it's because it's electron transport chain and oxidative phosphorylation pathway. Okay, one of the other tissues that has membranes that has a lot, of course, has to do with myelin sheath, of course, for the neurotransmission. Okay, whereas some of them, like adipocytes, have very little protein, okay, because it's primarily lipids. But there are other roles for the mitochondria. So these non-OXPHOS roles include thermogenesis, which we just started to cover just a few minutes ago, steroid synthesis, and apoptosis, which apoptosis is cell death. Okay. So I think I'm going to probably I'm just barely going to touch upon steroid synthesis because we're going to cover a little bit more about some of those with respect, hopefully later on with respect to hormones and stuff like that. But just to know that steroid synthesis, a lot of it occurs within the mitochondria. Okay, so thermogenesis. What is thermogenesis?
Generation of heat.
Oh, that's right. I could have sworn that you almost looked at it ahead of time. But you didn't. It's literally the beginning, the birth, the generation of heat. Okay, and the tissue that's most associated with that is the brown adipose tissue, or the BAT. Okay, and does anyone know why is it called brown adipose tissue?
Because it always has like a brownish color.
Right. Versus what's the other kind of? White. So we have brown, we have white. Okay, and it's brown because there's much more access to capillaries associated with the adipose tissue, brown. And then the fact that it has considerably more mitochondria. Mitochondria are dense. They're so proteinaceous and compact and everything. And white adipose tissue has very, very little mitochondria because, it's not that they're static. They are dynamic. I mean, that's our energy storage, long-term energy storage, but they don't need mitochondria like brown adipose tissue does. Okay? And another thing that's different is that the cristae of the mitochondrion transverse it. And I know you're going to be jealous of my ability to draw here, but this is the outer membrane. What is the cristae of the mitochondria? I'm only drawing mitochondria. The fold-looking things. And so for the inner membrane, and I mean it really transverse. There we go. So it's really fingery. I don't know what you want to call it. Okay. Because what occurs there? Right. This is where we have those spearsomes and all of the electron transport chain occurring and oxidative phosphorylation. But what happens here is that it's got something else. The big difference is the cristae here also has that protein that's called thermogenin, which is actually named specifically for what it does. And in the previous lecture, what I was talking about was it's like the open gate at the Duke football game. Why go through the turnstile when you've got thermogenin, an open gate? So all these protons that have been pumped across from what complexes pump protons across? 1, 3, and 4. Okay. From 1, 3, and 4, they pump them across to the inner membrane. And what complex pumps it from the inner membrane space? Normally, from the inner membrane space to the mitochondrial matrix. ATP synthase. So normally it goes through this way, but it doesn't here because this is open. So it just goes through there. And so because of that, it's called an uncoupling protein. It uncouples oxidative phosphorylation from the electron transport chain. Now that's not showing you complexes 1 through 4, but just for clarity's sake. So you still have this proton gradient, but it goes through here. And as it goes through there, it gives off heat. So what are, I didn't have it on here. So where do we see brown tissue? Like what organisms and species and things like that we're going to have a higher concentration of brown tissue? Pardon? Babies, to help keep them warm. What else? What about animal-wise? Like why would some animals have brown tissue? Bears, things that hibernate will have a lot more, right? Because it's how they keep warm while they're sleeping. All right. Like I said, I'm very briefly going to go over steroid synthesis. There are a couple of tissues that can undergo what's called mitochondrial steroid synthesis, and these are your adrenal glands and your gonads. And it should make sense why these tissues do, since these are the tissues that produce these steroids, right? The steroid hormones, which is what we're later this semester, I'm hoping that we can go into more details about the steroid hormones, like sex hormones in particular, and the corticoids. Okay, I don't know that we cover, I don't know that we'll have time to go over vitamin D in great detail. We went over a little bit last semester. Actually, I don't know that to be true because it's in the lipids chapter. So hopefully you got mentioned as in the lipids, because I think that's right at the time that it would have been when you first started covering lipids last semester. And these enzymes typically utilize, or I should say these enzymes are called P450 oxygenases. And this is a new class of enzymes for us. We've had oxidase, which what did oxidases do? Or oxidoreductases are related. What kind of reactions are they involved in? Oxidation, redox reactions. These are also, but they use elemental oxygen. And so we have monooxygenases and dioxygenases. And we're on target to be able to go over some of them. And so that shouldn't be an issue. All right. In the last 5 minutes, I really want to talk about apoptosis. And I got this all broken down in future slides. That way we can see it a little bit better. But apoptosis is programmed cell death, not to be confused with necrosis, which is another way for cells to die. This isn't naturally occurring. Perhaps for a song for this one, I should do like Hakuna Matata or something. The circle of life, the circle of life, that kind of thing. Because there, like it says in Ecclesiastes, to all things there is a season. Faith integration. I had to point to that one. Okay, so there is a time for that cell to die. Because if you don't, bad things could happen. And you could have organismal, you could have a systemic condition that occurs. Okay, and so whenever that cell is in trouble, you need to have a way to know in order for that cell can die. All right. So you can kind of think of it, and this is an oversimplification, but that cell dies for the good of the organism. I like that term. All right, so I've broken this down. So let's say there is some type of stressor showing this cell is in trouble, in particular the mitochondria here, but this cell is in trouble. It can be things like DNA damage. It can be reactive oxygen species. It can even be stressors. Okay? But there's something wrong. And what happens is, if you remember, cytochrome C was a part of the electron transport chain that was not in the intermembrane space. In the intermembrane, it's in the intermembrane space. So whenever these stressors occur, they trigger what's called the permeability transition pore complex. And this becomes, the fancy word for it is fenestrated. I've used it a few times. Fenestrated means holy, porous. Holy as in, not praying holy, but as in Swiss cheese holy. Even though I know some people who almost have a religious fascination with cheese. Okay, so then what happens is the cytochrome C leaks out into the cytosol. And when it leaks out into the cytosol, it activates a APAF1, which stands for apoptosis protease activating factor 1. And it forms the apoptosome, which really sounds very apocalyptic, I think. The apoptosome. That's an awesome name. Okay. So if you notice, we have cytochrome C on the ends of the individual monomers that have come together to form this polymer in the apoptosome. Then what happens, so we're not done, even though it's called the apoptosome, we haven't killed off anything yet. I sound a little too happy about that, but what happens here is it's the apoptosome that's going to activate the caspase pathway, signaling pathway. And we talked a little bit about that in some of our classes, where a lot of these caspases are enzymes and proteases, but they are always in a precursor form called Pro. So the apoptosome is what activates it. Okay, and I won't ever ask you to memorize the numbers. I don't even know how they come up with the numbers, where it goes from 9, and the 9 activates 3 and 7, and then these are the ones that actually are responsible for cell death. The important thing here that I want you to take home is the role of cytochrome C and APAF1 in forming the apoptosome to initiate this caspase pathway, which is what will present itself to the cell membrane to say, okay, it's time for the cell to die. Okay, you've got the execution sentence has been given, and it's not the only way, by the way. There are some other ways for apoptosis to occur, but this is one of the predominant ways.